in preparation for this, and it's actually a little too warm.
So that's the stereotype about Poland. So that you have to pack your coat.
Yep.
Okay, let's back to the topic. So what would be the topic of your talk?
I'm going to talk about scaling your app for emerging markets.
Okay, so let's talk about the scale market.
All right, do we have a slide? Yay! Hi, I'm Daniel. Thanks for coming to my talk. I promise there's beer after this. So today I'm going to talk about how I and my friends at Facebook have been changing our apps for what we call typical Android devices. So this graph, I'm assuming everybody has already kind of knows. This is the graph that Google wants you to know, that Android is massively more popular than iOS. There's way more devices out there. But in addition to like these total active device numbers, we know things like there's actually more app installs on iOS, regardless of this, and the Apple users are more active on e-commerce. So the majority of people on smartphones, trending towards the vast majority of people on smartphones, are on Android, but they behave in ways that we don't know, we didn't understand. Okay. Now Facebook's mission is to connect everyone in the world. So in order to do that, if everybody in the world is on Android, we need to understand what Android is, or what people's experience on Android is. And so we knew anecdotally that you could buy a cheap phone, and if you're on 2G in rural India, it's a terrible experience. But we didn't really have any way of characterizing how many people that affected, how much it changes their Facebook experience. And so my friend Raghavan came up with this idea of we wanted to identify what the typical Android user is, right? Because we knew that it wasn't somebody on a flagship phone on an LTE network in Silicon Valley. Okay, so we went into this project trying to figure out what are the bad assumptions that we made based on our experience with iOS back in 2011, 2012. Facebook, essentially every Facebook employee was on iPhone. The few people that had Androids were flagship phones. Okay, and so we needed to break our assumptions from iPhone, and then also the Facebook as a company grew up with a generation of people that were on laptops. So again, much more capable devices, bigger screens. So we're trying to adapt. Okay, so with this realization, we started sending research teams out around the world to go to a bunch of different sites and see how people actually experience Android in their countries. Okay, so here is a picture of a phone store. This is in Kenya, and yeah, they're selling a lot of used phones. We also in the U.S., and I was trying to do a little shopping last night for phones here in Poland. It seems that they want to sell things on contracts here too, right? You get your phone and your service from the same provider, or at least that's how they want to sell it to you. I don't know how many people actually do it that way. But in Kenya, it's very different, and in a lot of countries, buying the phone is completely separate. You buy the phone one place, and then you go in and you get a SIM and you plug it in from somewhere else. And they have a very direct, on-the-street marketing of phones. Okay, and then we also talk to lots of people, right? So we go into their homes or catch them in a mall, basically ask them to use Facebook for us, and talk about why they chose this particular phone, what they expect Facebook to be able to do for them. Okay, and so three major themes kind of emerge from that. So the first one is how you buy data, right? So standard in the US is this notion of contracts, right? Versus in a lot of parts of the world, instead you get prepaid, right? So you have money on your SIM, and then you buy data going forward. We buy data by the gigabyte. So typically you have a plan of a gigabyte a month or 2 gigabytes a month. That's easy for providers to understand. But in some countries, they market it very differently, right? So in the Philippines or Thailand, they have these plans where basically you can buy 15 minutes of access to typically, sometimes it's the entire internet, but usually it's just a suite of applications. But you essentially have unlimited use for 15 minutes or an hour or a day for some amount of money. And this is driven by unreliable income, right? So people don't just turn on data access all the time, right? They buy a chunk of data when they want to use an app. They let that data run out, and then they buy data the next time they want to use it, the next time they have money available to do it. This drives a huge difference in devices, right? So when you have a contract that really hides the price of the device, as far as Americans are concerned, a Galaxy S5 costs $200 and a Galaxy S4 is free. I saw here last night somebody wanted to sell me a Galaxy S9 or a Galaxy S4 for 9 zloty, which seemed like a really good deal. But that doesn't reflect the true price of the device, right? In a prepaid market, you have to pay the full value of the device up front, and that means that $100 is a much more reasonable price. And so the upshot is, instead of a market that is essentially all flagships, you have a market where the technology is a generation or two older. Lastly, screen size is different when you move to different countries. In America, we kind of have a bigger is better ethos, and so phones just keep getting crazier and crazier. But not every culture is bought into that, so some people prefer smaller screens. Okay, and then lastly, networks. So in developing countries, they tend to have not already paid for their infrastructure, right? So they're still paying off their 3G towers. They may not have deployed 3G towers across the whole country in the first place. They're certainly not going out of their way to get LTE up anytime soon. Okay, and so whatever 3G towers are there may be suffering from congestion, either from too many people on the local cell network or on the backhaul, trying to get out, international and get up to a Facebook data center. And then lastly, Wi-Fi. So in some countries, Wi-Fi is kind of ubiquitous. They have it publicly in malls. Mexico is a good example of a country where there's kind of public Wi-Fi everywhere and people just rely on it. But in other countries, don't have this culture of public Wi-Fi networks. So it doesn't act as kind of a fallback to always have good connectivity, at least when you're near a hotspot. Okay. So the upshot of that is, I think this is the graph that matters more. These are, I don't have a scale on here, but these are much bigger numbers, right? So Android is really what's happening is there is this flagship market where Android is competing against iPhone, and that's kind of interesting. But the bulk of Android is actually killing this feature phone market, right? It's finally bent the curve on feature phones. Feature phones are going away, and cheap Android devices are becoming the new feature phone. This is a much more democratic platform. We're getting to the point where everybody who owns a phone can afford a budget Android smartphone. So it's very different from these, pocket supercomputers that probably everybody here is walking around with. Okay. All right. So as we started getting these insights from these research trips, it gave us ideas for how to parse our data more, and we were able to pull out kind of these 3 independent variables. They correlate together somewhat because to some extent they all reflect how much money you're willing to spend or you're able to spend on your mobile phone experience. But in different countries and for different people, you can see that they vary quite a bit. And this made us really excited. So in the first talk here this morning from Cassie and Rachel, they talked about using segmentation. They had a New Relic slide up there where they're analyzing, you can tell if you have problems on iOS or Android where you need to focus your effort. At Facebook scale, when we just say, oh, we have a problem on Android, that means hundreds of millions of people. We need to segment smaller than that, right? So being able to segment on device capabilities or network capabilities is a big deal for us. Okay, so let's talk about slow phones first. This one build for me? Yeah. So at the same time as the number of users of Android has grown exponentially, the number of devices has grown exponentially as well. And they're changing in kind, right? I mean, like at the beginning, you had like these hardware buttons. Then you started to get larger and larger touch screens. The buttons moved like onto the screen. And yeah, screens just keep getting bigger. Okay, so yeah, and these phones don't really get retired. So like all these models are still out there. And in any given month, we see tens of thousands of different Android models coming in. Okay, so unfortunately, Google did not supply an Android API for how good is my phone. So we wanted that, and so we came up with this idea called year class. And basically, the idea behind year class is for any given device, you look at the specs on that device and you say, okay, when would this have been considered a totally bitchin' phone, right? A top-of-the-line flagship. Okay, and so for the actual flagship phones, that's pretty easy. These are some flagships from days gone by. You can just kind of slap that up on a calendar year basis, and that's pretty easy. And in a market like the US, basically the only phones you can buy are either this year's flagships for $200 or last year's flagships that are free. And then that's basically all the phones that we see. In prepaid markets, Samsung and a lot of other competitors basically develop these new phones, brand new phones, that are using technology from 2, 3, 4 years ago. And they can sell them for, $75 or $150 or $200. Instead of the $600, $700, $800 that a new flagship phone costs. Okay, so basically the system of year class just says, okay, we're going to look at how many cores, the clock speed, and what the RAM is on the device, and try and map it to a flagship. So as an example, I have my trusty Moto E here. This phone was released middle of last year. It's got 2 cores, runs at 1.2 gigahertz, has a gigabyte of RAM. The Samsung Galaxy S2 was a flagship back in 2011. Very conveniently, it has 2 cores, runs at 1.2 gigahertz, and a gigabyte of RAM. The mapping doesn't always work out this well, so you have to figure out how to round those things. But we just say, boom, both these things are year class 2011. Okay, so when you do that with all the phones that come in that we see, we basically segment into, well, you can kind of segment into 3 markets. So stuff that's 2010 and below, 2011, and then newer than 2011. So, yeah, what was I going to say about that? Oh, right. And so like this pie chart is actually showing like total number of people on these types of phones, right? So really it is kind of a third of the market is, for lack of a better word, low end, this 2010 and below. A third of the market is at year class 2011. That's kind of the sweet spot in the market right now. And a third of the market is this high-end market that is effectively the set of Android that's competing with iOS. Okay, and these chunks roughly correspond to single core, dual core, and quad core. Not exactly, but that's a good general rule of thumb. Okay, so kind of one of the first things that we thought about this is like, okay, so maybe this is just a problem that solves itself as time goes on, right? People start buying better devices. We've been tracking this for about a year now, and in that year, the median year class phone has only gone up by about 5 months, right? So this problem is not solving itself. The Galaxy Young 2, or let's see here what I have. I have my trusty my trusty Pocket Neo Hello Kitty edition. This phone's from 2013. It's been kind of surpassed by the Galaxy Young 2. But that's a single core phone. It sells for about $80, and they've sold millions of them this year. Introduced in September of 2014. So basically, enough of those new phones are basically, so the 2010 and below class is kind of holding steady. There's enough new devices to make up for the devices that are being retired. The growth that we see in Android is basically evenly split between 2011 phones and newer phones. And I think that this is going to continue happening, right? Because what's really happening is the price point is just going down and down and down. There are more and more people that are able to afford these cheap Android phones. Okay, so internally, we basically lump anything that's 2011 and below and call it typical Android, like I was saying. So but essentially, you have the high-end version, the high-end phones that are competing with iOS down here, and typical Android is the rest of it. And what was I going to say? Oh, so one of the things that Chi talked about in his talk, if you went to that one, was that in order to be successful, developers and designers have to have empathy for their users, right? They have to understand their experience, and that's really hard to do if you don't understand their devices, right? So basically, every developer at Facebook has, a phone like this on their desk and a phone like this on their desk, and then their high-end phone that they usually carry around. These are painful to use. I don't recommend walking around with this as your daily phone. But phones like the Moto E here, dual core, relatively slow. This is a good expression of the experience that your users are actually having. And this is a totally usable phone. We encourage developers and especially designers and PMs to use this as their primary, to use this or a similar device as their primary device at least half the time. Okay, so So once we had this year class metric, we started like looking at all our stuff broken down by various things. And so like there are a lot of things that it could show, but I like this one, which is it shows the relative crash rate of various devices. So you can see on flagships, we have if we have a given crash rate of however many crashes per week, as your phone gets lower and lower spec, the number of crashes goes up and up and up, right? We have really been failing users on lower end phones. For us, this is a lot of out of memory errors, but there's all kinds of weird errors that seem to only show up on phones where we're essentially taxing the limits of what the hardware can do. Okay. You can also use this to help guide your feature design. So this is a new comment flyout that we introduced last summer. This is one of the first things that we really tested with your class. So this thing's kind of slick. It has a bunch of animations. And when we initially tested it, again, using kind of A/B testing that everybody has been talking about in their other presentations, this was positive, right? We saw more comments coming in from people that had this design. But the story changed a little bit when we started breaking this down by year class. Okay, so that number's a little small, but that says 2009 down there at the bottom. And so basically what was happening is there was actually a big chunk of users whose commenting activity went way down with this feature in place. And it was kind of being washed out by the fact that there's even more users that were going positive on these higher year class phones. So given that we saw that, we were able to essentially ship the feature to everybody on year class 2011 and up, and then continue working on it for people that were in 2009, 2010. And in this case, the answer was just do a few less animations, and then their experience went positive as well. All right. Whoops, wrong way. Screen size, let's take a look at sizes. So starting in roughly 2012, flagship phones have had HD screens. And so starting about in 2012, we did all our design on HD screens, most of our development on HD screens, and kind of figured that, again, at that point, we were still kind of assuming that the fleet was moving up pretty quickly, and everybody would have an HD phone. That's not the case. So we still have roughly half of the active Android devices out there have essentially a 480 by 800 screen or smaller. So having seen that, we started to go back and kind of reevaluate some of our choices that we made, assuming that people had HD screens. So let's see here. So newsfeed, it scales down. You can't show as much, but it still is essentially newsfeed. Timeline looked really bad. So when you get on a small phone here, essentially the only thing you have is the cover photo. There's no information at all. Events has a problem too. That information is kind of okay, but that plus up there in the top right that actually allows you to add a new event, if you have a small enough screen, that disappears, so you can't create events anymore. All right, so this is the new version of Timeline. Cover photo is shrunk way down, so we can actually get some information on screen as soon as you load someone's timeline. And we download this fuzzy version of the image, and that just makes it come in faster, right? Instead of loading this high-res image at the top and all the bytes that entails, you can get it. You can get the page in faster. And then for events, we did a total redesign, basically to make the use of space much better. Okay. Instagram started out with a pretty spare design in the first place, but when they started considering typical Android devices, they wanted to get some pixels back from their Chrome. So by ditching kind of their vertical bars and drop shadows and extra bars in these panels here, they were able to get 20 pixels back, which is more than nothing. It lets you see an extra line on this photo. And they really went all in for a flat design redesign. Okay, so Google has been kind of pitching flat design as a feature of Android L. You've got the tint parameters, but color filters have been around since API version 1, right? So you've been able to essentially do this trick of just having a single asset with a shape and then coloring it programmatically whatever you need to display it, right? So often you're going to have an asset where there's kind of an unpressed state and a pressed state, or an active and inactive state, and instead of if you can ship one asset instead of two, that's going to be better because your APK size is going to be smaller. The second part of this is that when you're loading fewer assets, your UI is going to come up faster and use less memory. And then ultimately, this is usually going to give you faster iteration just because you have less assets to cut. Okay, and so when I did that whole hog, at the top bar, going from taking out these drop shadows and taking out the vertical bars lets them go from 6 assets to 3. Down here is where it gets crazy. So this toolbar, getting rid of extra press states and all this extra crap in the Chrome goes from 23 to 5. And so kind of the side benefit of cleaning up the design is the app started 120 milliseconds faster. At the time, that was roughly a 10% reduction in cold start time. And it didn't stop with just starting the application. Basically, this makes everything in the app faster. Okay. So that's kind of screen size and a little bit more about speed. So let's talk about connection quality. Okay, so network characteristics change a lot based on what region you're in. So we need to figure, and we wanted some way of kind of characterizing this. So this data is about a year old when we first started looking at this. And says basically by geography, the US is about 71% covered, but India is only 7% covered. Brazil's clocking in at a little under 40%. Again, this is because in these markets, carriers have not had time to get all their revenue or pay back the cost of all their towers and continue building out. So in addition to having less coverage, these networks are also a lot slower, right? So the latency coming from India or Brazil was recorded at being 2 or 3 times longer than the latency to the US. Okay, so we started measuring these things. So these are for the same radio technology, so Edge, HSPA, LTE, Wi-Fi. This is measuring latency, but the same things worked for bandwidth as well. Essentially, what we saw is that on every one of these technologies in Brazil or India, it was 2 or 3 times slower than it was on the US for the same, essentially for the same radio type. Okay, and then also you can see that in India and Brazil, LTE is actually faster than Wi-Fi. On this thing, shorter bars are faster. So all the places that are in our code where we say is on Wi-Fi, assuming that means is on fast network, does make me want to cry. Okay, so this kind of gives you an idea of how noisy. So if you just said, okay, you're on HSPA, therefore I have a reasonable expectation of how fast your network is, we can see how wrong you'd be based on country. When you look at the actual individual user traces, it's of course way worse than that, right? Because individual people, sometimes they have 1 bar, sometimes they have 4 bars. You walk into the subway, it's kind of terrible. So what can we really do about this? So what we started doing is we measure the throughput of every response that's coming into the app, okay? And kind of use that to passively observe the download speed that the app is doing. Likewise, our Facebook servers add a response to the header that indicates how long it took to set up the TCP connection, so we're also getting an estimate of round trip time. And then the client maintains a moving average of both of these values. The downside to kind of passively measuring network speed is that it is unbelievably noisy. Right, if you use an app like speed test, it essentially pushes a couple megabytes of data up and down in order to actually get a pretty reasonable measurement or a pretty repeatable measurement. We don't really have the option of just saying, oh, every time you launch Facebook, we're going to use up 2 megabytes of your data plan. That's not a good approach. But the downside is that this stuff is incredibly noisy. Anyway, so once we start collecting those numbers, basically the same way that I showed you that bar graph before, we were able to start plotting various types of activity on Facebook against your average bandwidth. So this graph is showing bandwidth going up on the x-axis, and this thing over on the right that I've labeled story consumption rate, this is basically a measurement of how quickly do you read stories in newsfeed, okay? Which is kind of a good metric for us. Like reading newsfeed stories is kind of where all the engagement in Facebook begins. Right, so this is kind of the top of our funnel. So this is what we wanted to look at. Okay, and you can see over here at the right, it kind of flattens out, right? So essentially, once you get up to, I don't know, 4 or 5 megabits around in here, then essentially the network is fast enough that it is no longer interfering with your experience, right? And then as your bandwidth goes down, it interferes with your experience. It takes longer for you to read stories, right? It starts slowing you down. And so based on this, we kind of defined some buckets. So the same way in your class we define these buckets, of 2009, 2010, 2011, 2012. We define these buckets of excellent, good, moderate, and poor, right? And so good means that we think that how quickly you can read stories has been impaired by about 10% versus like having a perfect network, right? Moderate is you've been impaired by 25%. Poor is you've been impaired by 40%. And those are kind of arbitrary, but it gave us something to work with. Okay, and so now we have these buckets that we can tell feature developers about, and they can start thinking about how to use that. Okay, so some things that we've done. Some things that we've looked at. So this is how fast you can bring Facebook back into the foreground when it's already running. So this is an operation that unfortunately involves a whole lot of CPU and only a little bit of network. But even for that operation, you can see that the time that it takes to do that starts to go up quite a bit as the quality of your connection goes down. An operation that's much more network sensitive, such as when you're scrolling through newsfeed and you get to the point where you need to load more stories at the tail. So that's something that's much more network sensitive. You can see that on a poor network, you get way slower. And this is actually more than just the amount of the actual network call to fetch the new newsfeed stories, right? People in the poor bucket are still downloading the photos that are already on their newsfeed, right? So that's already clogging their networks, right? So these effects kind of compound when your network speed gets really bad. Okay. We can also start looking at the network qualities in different countries. So it turns out in a lot of countries, in most developed countries, most people have pretty good network almost all the time. So this is actually Poland's graph. And at least as far as Facebook can tell, roughly 90% of the time people are on excellent or good networks. This actually looks very similar to the US. Now that includes Wi-Fi too, so I don't know, I didn't check to see what percentage of FE4A access in Poland is done over Wi-Fi, so that may color it a bit. But if you go to India, you can see half of people are on networks that are poor or moderate, right? So these are people whose Facebook experience is being impacted severely, right? 25 or 40% or more. Their ability to read news stories has gone way down. And this doesn't only happen in emerging markets. So Japan is kind of fun because for the most part, it's really, really good, except for the end of the month. And so I think that's because people are hitting their data quotas and they're getting capped, but I haven't actually gone and proved that yet. But anyway, I bring this up just to point out that even folks in very rich, very developed countries, at least part of the time, they get capped, right? Their experience starts to get very slow. Okay, and so now that we have kind of this feature of bucketing people into various connection class buckets, there's a bunch of stuff we want to try. Now, we've only been doing this for a few weeks, so I don't really have any successes or failures to talk about too much just yet. The one that looks best so far is prefetching additional data. I think the biggest thing that we've learned there is that for people that are on very fast networks, prefetching is a net negative, right? The extra time that the device is busy processing the network calls interferes with it, like scrolling smoothly or doing other things well. Right, so actually, when you're on a very fast network, stop prefetching. Conversely, when you're on a slow network, prefetching makes a lot of sense as long as you're actually going to use the data. Okay. The other things that we're trying, we want to dynamically increase or decrease the amount of image compression that we're doing to make the photos smaller or bigger. Issue more requests in parallel. Right, you can have more things outstanding when you know the network can support downloading lots of photos at the same time. And then enabling or disabling autoplay on videos. Okay, so once somebody builds a feature, they need a way to test it. The way that we do that inside Facebook is with an app called Air Traffic Control. So air traffic control is implemented on a couple of our Wi-Fi networks, and it basically lets you go in and change it so that while you're on that Wi-Fi network, your network experience actually emulates the 2G the cellular conditions in another country. And you can actually dig in and set the specific values. You guys can do this too. If you're using an emulator, you can run through Charles or some other kind of proxy. Most of well, at least Charles and probably some of the other proxies give the ability to kind of throttle down your effective bandwidth, so you can get a sense of what that feature is going to feel like. Okay. So those are the kinds of things that we kind of do speculatively. The other thing is just like in general, so I talked about how like tail fetching was getting really slow because you were getting this compounded problem of like you're still trying to download the images from the last thing you tried to do. And so just in general, we wanted to figure out, okay, can we cut down the total amount of data that we're sending to people? Okay. And so for these markets, for people that are constrained, we ignore video. For the most part, videos, you know, they don't use video because it just doesn't work very well for them. So when you look at everything that's left, in our app, images totally dominate. And I think that that's probably fairly standard. This is just saying, so 85% of the data into FP4A, again, accepting videos, is images. 10% is kind of API responses, it's fine, whatever. And even in Messenger, it's 65%. Okay, so we started to change how we think about images. Developed this philosophy of when you get an image, you want to send the right resolution in the right format, compressed appropriately. So what does that mean? So your source image is going to be large typically, right? Because you know at some point you may need to display that full screen on the phone. When you're just displaying thumbnails, you don't need the 960 by 960 image, right? You can just send down, particularly if the odds that the user is going to look at the full scale image is small, then you can save a lot by just sending a thumbnail or a preview. Also, if the device is like my Hello Kitty Pocket Neo, it's only a 240 by 320 screen. A 960 by 960 image is just a waste. Okay, so let's look at the primary use case for Facebook, that being cat pictures. So we used to always request this big image in Facebook whenever you were getting a full screen image. Sorry, which is just a giant waste, right? Really, you just want to get a tiny cat picture image and stick it in there. And so in this case, this image compresses 86% smaller when you just shrink it so that it actually fits the phone. Even for, you know, even on 720p, right, we get almost 25% savings by shrinking it down to make it fit the phone. Formats. So kind of the standard format for photos is JPEG. Google put out WebP in 2010, and it's pretty well supported from Android 4.2 and up. And they touted it as compressing better. We wanted to explore that. So here's our cat picture again. I got two versions here. I can't really tell the difference, and it's not really the screen. I can't tell the difference on my laptop either. The left one is JPEG, the right one is WebP. In addition, the right one has had its quality parameter turned down a little bit from where we had it on JPEG. So this picture is actually 27% smaller than the one on the left. Right. Okay, so from our experiments, and this varies based on your photo corpus. Like this is something, if you're thinking about switching formats, you actually need to test example photos from your app. But at least with Facebook's corpus, the WebP pictures on average are 7% smaller for an equivalent result. The bigger thing that we looked at is the quality knob. It turns out that we were just generally sending too high of a quality of image and could make things almost 20, so an additional 23% smaller by doing that. There's no noticeable change in user perceived quality. Again, this is where you take advantage of your A/B testing. You can basically tell that, yes, there is no perceived difference between these things. But we actually do end up serving JPEGs because JPEGs can progressively render. And what that means is after you've downloaded a portion of the photo, it will allow you to render a lower res or fuzzier version of the photo while you wait for the rest of the photo to come in. Right? And so the perceived performance of being able to show that fuzzy image is a big win. So WebP theoretically will support progressive at some point, and then we'll be happy about that. The other side of this is for line images, so pings. WebP supports transparency and animation, which is really important for us for stickers. Here's kind of one of our favorites, Pusheen. So Pusheen over here in ping is 132 kilobytes. He goes on the world's best diet and looks exactly the same and only takes 29 kilobytes in WebP. Okay, so I mentioned that WebP really only works for 4.2 and above. So if you can do WebP on lower versions, but it does mean that you're going to have to ship the WebP SO, and you're going to have to convert from WebP to JPEG on the fly to decode like that. Also, encoding WebP takes a lot more CPU than JPEG. So if you can't do that, you should at least get the Moz JPEG encoder. It is so yeah. So the decoder is the same. JPEG doesn't actually specify an encoder specification. It just specifies what the decoder looks like. So when you get a better encoder, it just makes your JPEG better. All right. So some takeaways. Android really is the world's platform. It is the largest platform, largest computing platform on Earth, and it is just getting bigger every day. There's a wide range of experiences, and you can address your user base a lot better when you treat them as segments and treat them or give them products that meet them where they are. That's it. Thank you very much.
Let's change the order. Are there any questions here? Okay. The first one.
Hi.
I have one question about battery drain.
Yeah.
The Facebook application still kills my 2011 phone in less than half a day. So, do you have any techniques or plans for how to manage with it?
Turn it off.
What's that? Yeah, short answer is no, I don't have a good answer for you. We are aware of the battery problems. We do track battery usage. It is a hard problem that we have not figured out how to master yet. Sorry.
Hello. So actually I have two questions. One short. How long it took for Facebook to gather all the statistics and figure out how to do the strategy for all this stuff? And another one, for your glass phones, people say that latest Motorola phones, even the Moto E, they are more fine-tuned and better with better firmware, and the same hardware does not always mean same performance as on other phones.
That is absolutely true. So I'll go in reverse order. Year class is an incredibly blunt instrument. We have not. My current guess is that we get year class wrong about 20% of the time. And even as bad as it is, it still has been incredibly powerful for us in terms of doing things. I do look at other metrics. So like when I just look at cold start, so the problem, right, is when you have 10,000 models, you can't meaningfully separate into 10,000 bar graphs. But I do like go in and look at things like cold start time for individual phone models inside a year class. And the Moto G is like probably our biggest outlier. The Moto G ranks out as year class 2011, and it performs like a year class 2013 phone, basically. So yeah, so year class is far from perfect. I'm sorry, I already forgot your first question. How long did it to do data? We started seriously working on year class in April of last year. We already had a lot of instrumentation in there to collect it, but it took us about, I don't know, a month or a month and a half to kind of formulate that and run it through enough math to say that we believed it. Connection class, I kind of had to build more from scratch, so we kind of built that. We built the data collection stuff in June, July, August of last year, and you guys are seeing essentially the first kind of graphs out of it. So that took about 4 or 5 months.
Okay, we have a room for 2 more questions and 1 more.
What do you think about emerging market programs by manufacturers like Android One, and are you guys equipped for it?
Equipped for it? We're super excited about that. Anything that lowers the price point of good Android hardware is a huge boon for us. Like I said, so far that program is not having a huge influence, right? I think kind of the Moto G and Moto E devices probably kind of set the standard in terms of price point in a way that I was hoping Android One would redo, but it hasn't really done so far. Certainly not until they start shipping them in more countries. They went for a really high hardware spec on that stuff. The screen is relatively small, but it's a quad core that like those things are little monsters. Which again, so like that's great. We wish that everybody had an awesome phone. We don't live in that world yet.
I also had a question very similar to the previous one. I mean, it took some time to gather all the data, right? And at the end, you can easily say that it's better to see you use WebP instead of PNG files, most probably, yes? But my question is, as an Android developer, should I feel ashamed that I don't use all this optimization just like you at Facebook? Or is it just a matter of scale and long living product?
Thank you for answering the question.
Okay.
But in all seriousness, right? We have, I don't know, there's 150 people that are kind of full time thinking about Android, and we have me as 150 developers, and then there's additional product managers and designers and all those folks, and we have me that's worried about that, right? You need to be, you need to have a large enough user base that you're like, crap, we need to segment this. So yeah, I am certainly not, like most applications just use Picasso. Like, just get your app out as fast as possible. Like once it scales, that's the right problem to have, right? So hopefully this stuff is kind of helpful in terms of like knowing like what the future might hold. But yeah, I certainly don't expect people to think about this in the early stages of an app. Like this is optimizing for a mature app that has a large audience.
Okay, and the last question is from me.
Yeah,
of course. Do you like talking tech stuff while drinking a beer?
I do.
So let's make it happen. Okay, thank you very much, and let's join with the beer.